see what you're pointing at.
Is there like an option?
Yeah, so the third one.
So that one.
Yeah. So, yeah, it's a bit more difficult for you, but
yeah, we'll see how it goes. So. Is that everyone?
Yeah, I think so. So let's make a start.
Okay, yeah, good afternoon, everyone. So I know a few of you, but for those that you don't know me, my name is Sam Sharp. Basically, I run a small one-man alliance partner, basically doing contracting and sort of LabVIEW systems and LabVIEW and test stand systems. I'm a LabVIEW champion, and I'm not quite a test stand architect. Just haven't quite got that far yet, but I am a LabVIEW architect and a certified embedded developer.
You're slacking on to. You're slacking on to.
Oh, I've got to leave something to look, something to look forward to and work towards. Have all of the badges. Okay. So introduction. So I'm going to talk to you a bit about Malleable VIs. So it's kind of just an introduction, really, and to kind of show some of the cases where I thought they were useful, and basically to kind of inspire you to go out and have a go at creating some for yourself. So this kind of the presentation came about as when they were released in LabVIEW 2017. I kind of started writing a few blog posts about them. So there's a link at the bottom there to that if you're interested in checking it out. Stephen Loftus-Mercer, so Aristos Q, in the who works for NI, basically he gave a sort of a presentation kind of introducing some of the concepts for Malleable VIs, but the differences that I'm going to show you a few sort of practical examples from stuff that I've done that I've found them useful. So yeah, it's really kind of designed as this is what Malleable VIs are, and to basically sort of encourage you to go forth and fire up LabVIEW and have a go at creating some Malleable VIs. So what is a Malleable VI? So basically, it's a special type of VI where the input and output terminals automatically adapt at edit time to the wired data type. So it was a feature that was introduced in LabVIEW 2017. It was made a lot better in SP1 of 2017. I think it got better in 2018, and as I found out when I was kind of revising this presentation for today, they're even better in 2019. So basically, the way you create a new Malleable VI is file new, and basically one of the options there is Malleable VI, and that kind of sets up the VI. But essentially, basically, if you save any VI as a .vim file and enable inlining, that basically is is the same thing as creating one from scratch. So you can take an existing VI, convert it to a Malleable VI, and vice versa. You just have to remember that basically a Malleable VI is kind of inlined, so you have to kind of tick that box, and if you don't, it'll tell you that there's a problem with that. So to kind of compare Malleable VIs to other languages, so basically it kind of similar to generics or templates, but kind of in the LabVIEW world, the way we kind of did this was either using polymorphic VIs. So this is where you create an instance VI for each of your different data types you want to support. And also there's kind of the dragon that is Xnode, sort of an unsupported feature that kind of allowed you to create your kind of own sort of primitive LabVIEW VIs that you could kind of, you could extend nodes and that kind of stuff, just like you do with build array and that kind of thing. So one of the sort of easiest ways to figure out what they are and to see what they can do is that LabVIEW 2017 onwards actually includes a bunch of shipping examples. So I picked out a few up here. So things like shuffle array, shuffle 2D array, these kind of primitive VIs with a sort of darker orange background. These are actually Malleable VIs, and I'm pretty sure that you can just double click on it and open it up, and you can see kind of the code behind it, as it were, to see how it's implemented. So you can use that as inspiration for your own stuff. So again, I'm sure quite a few of us have done this thing of stall data flow, where we want to pause execution on a specific wire, and so you put down a wait, and then you put a flat sequence structure around it, and then wire the error terminals through. And I've seen probably I don't know, maybe a dozen different variations of this VI, various companies and various bits of LabVIEW code. Well, now there's a VIM that you can just drop in on any wire type that you like, and it will basically like hold pause execution at that point. So there's a few kind of examples in the sort of array palettes, timing, a comparison palette. There's a few things like I think there's like a logger function that can basically like log anything you wire to it to a text file. So it's quite useful for like sort of debugging stuff. You can just drop this VI in wherever you like in your code, and it will basically log whatever the value is to a file. So that's quite a flexible thing. In LabVIEW 2018, basically like they introduced like a new structure into the palette, which is basically called the type specialization structure. So this basically is a structure that kind of allows you to do some more advanced things of basically controlling how the Malleable VI reacts to certain data types. And I'll show you some examples of this of this later. So why use Malleable VIs? So I think one of the main reasons is for code reuse. So if you've ever looked at the like some of the like OpenG and MGI like VIs that kind of do stuff on different data types, well, actually the way that they work is they are polymorphic VIs. So basically someone has had to go in and create a copy of exactly the same VI for each different data type that it supports. And it may be that there are some things in there that you want that things like cluster type definitions, for example, you couldn't do that on these, and it would just break. So basically the idea being that with Malleable VIs, you can replace all 30 of those VIs with just a single VI. So it kind of reduces the amount of code you have to write and maintain, and basically it'll work with any kind of supported data type. So as I mentioned before, like the Malleable VIs are inlined into your code, which means basically when your VI is compiled, the Malleable VI kind of gets opened out into the block diagram kind of in the background. So basically, as long as it compiles, then you know that you've kind of got a valid input. If you try and wire something crazy like a cluster to a sort 1D array, it doesn't really know what to do with that, and so it'll tell you, you've done something stupid, this won't compile, and it'll tell you about it kind of in advance. But if it works at compile time, then there's a good chance that your Malleable VI works for your specific data types. So some of the sort of like use cases where I think they're useful. So basically, like if you ever like looked through your code and you've seen a VI and you thought, oh, I want something that does this, but with a different data type. So you've gone file, save as, and you've created basically essentially the exact same VI, just with different output, input-output terminal data types. Well, maybe you should have a think about whether or not Malleable VIs would kind of work in that situation. Things like numeric and mathematical functions. So if you're doing some like advanced analysis, at the moment you just kind of default to a double, and you use a double for everything, and you have the coercion and that kind of stuff in there with that. But with a Malleable VI, you can basically, as long as you're doing sort of valid operations, you can do fixed point, extended, singles, doubles. I've had a situation in the past, quite a long time ago, where it was some VI I was using was coercing everything to extended, and we were building up a rather large data set, and it suddenly doubled in memory because of this one sub VI that was basically like coercing things from a double to an extended. So things like also like calibration functions, again, kind of working on the sort of numeric things, array manipulation, things like wrapping communication primitives. So things like, if you create like a queue API, or, you wrap some queue functions, well, typically they'll only work for the queue type that you've passed in. Whereas with a Malleable VI, it will adapt. So if you just want to like, enqueue a bunch of items into a queue, you can basically have a Malleable VI that can enqueue multiple, but it really doesn't care about what the queue data type is. And again, things like debugging, logging stuff, this sort of kind of built-in VI that can kind of dump anything to disk, or just sort of convert anything to a string and then log it to a disk is quite a useful like sort of bit of functionality. Can I just ask, like, who actually has like written a Malleable VI? Like, has anyone? So two. Okay, right. Okay, so what did you use them for, Sri? What did you use on?
Mainly APIs. I mean, so which are generic because I mean, packaging code is something that I generally do.
Yeah.
And I normally get a request saying that, okay, can I do this little bit more?
Mm-hmm.
And this helps me quite a lot. So just on the type specialization structure that you mentioned, it's available in 2017, but you have to go into one of the VIs that uses it.
Oh, okay, so it's hidden. Yeah,
so it is there.
Yeah.
And it also comes with a warning saying that it's an experimental feature, so
Yeah.
do not use it without testing.
Yeah, yeah. I'll come on to that as well a bit later. What about you as well, Larry? What did you?
Yeah, so I used to use it in the past, but actually, funny enough, back in LabVIEW 2013.
Yes.
It's been there since quite a long time, but they used to be called VI macros, and it was just a hidden forum post that sort of alluded to how to get them, which is just renamed to .vim at the end, basically. But my experience with that was that I had compiled it into our code we were using a lot across loads of stations, and then for some reason, a few months later, those VIs that I placed down, the diagrams simply disappeared. I just saw wires going into nothing, and then wires coming from nothing, and then there's no way to actually physically select the function anymore, so it broke our code.
Okay, yeah.
So
again,
they weren't supported back then.
Yeah, I'll touch on it again, but yeah, I also found that I had some code that I'd written in LabVIEW 2017 and saved it for LabVIEW 2013, and it still worked. So yeah, there's some kind of like, even though there was no kind of way to create them back then, it actually, if you like want to save something back to a previous version, it does work. But I'm putting like a massive red flag of almost definitely not supported, and good luck. So yeah, coming back just to kind of see what people were using them for. But so one of the things that I kind of found myself doing, like over and over again on multiple projects, was we used like ini configuration files, and so I kind of had some functions that would load the configuration from a configuration file and be able to save that configuration to a configuration file. And basically, like, this is the on the left here is kind of the code that I was kind of writing and reusing for kind of most of my most of these projects. But really, it's basically the same thing. I wire in a path to where I want to save my configuration file. I wire in some default settings, and basically I try to read those settings with the default, and if it can't find them, use the default values, and then basically I write that back to the disk. So basically kind of it initializes my configuration file when the program starts up, and then creates kind of like the sort of dummy or default configuration file. And these kind of the green, I think it's the OpenG ones, they're quite good for that, because it can handle, like, if you make a change to that cluster and then like reopen your file, it will load it in with kind of the default values that you specify and stuff. So kind of as your application grows and you start adding new configuration keys and stuff, then it still just works. Whereas like things like the XML functions in LabVIEW, like, they won't do that. So everything has to be right or nothing. So yeah, so that's one kind of case for it. And basically I found that I was kind of able to replace that kind of entire, this code here that I was reproducing for each project, and replace it with a single Malleable VI, where I could give it my cluster of stuff that I wanted to write to the configuration file, and a path, and it would basically write it and load it. And you can see there's no coercion dots, so there's nothing in there that it's not coercing it to a variant or anything like that. It's kind of treating it as the the cluster that I've passed into it. So the type specialization structure that I mentioned earlier, so yeah, it's a new structure that kind of apparently only appeared in the palettes in 2018, but was around with the release of like Malleables in 2017. But basically, it allows you to kind of force LabVIEW to handle certain data types in a certain way. So obviously, if I have I'm trying to think of a good example. So if I want to have something that can work on a path and a string, well, in fact, yeah, that's probably the easiest example to show you, is this one here, where basically if I want to have something where I can either wire in a string or a path, well, I want it to basically convert that to a string. Basically, I need to kind of convert that I can't just wire a string into a path to string function because that doesn't work. But what I can do is use a type specialization structure and say, all right, so for strings, we'll just pass out the string. For paths, we'll convert it to a string and then pass that out. For numerics, we basically say if it's a numeric type or a floating point numeric type, then convert that to a string, using the number to string conversion functions. And then at the bottom here, so for booleans, basically like flatten that to, I think, a true or false, for example. So there's a bunch of kind of palette things on there that basically, the way that the type specialization structure works is that it will work through the cases from 0 to however many you have, and basically the first one that will compile is the one that it will compile and put into, replace in your code. So that's kind of the way that works. It's not immediately obvious. I find working with Malleable VIs like a bit of they're quite difficult to kind of because it can kind of work with any data type and you can't immediately see that. It's kind of, it takes a bit of like, figuring it out in your head as to, how to get this to work. But I think it is worth, once you start playing with them, you get kind of more used to it, then it does kind of let you go, oh, right, yeah, okay, that makes sense. Okay, so the other example that I have is I do a lot of like UI stuff. And I find one thing that I do all over the place is, set enabled state. And I want to be able to set enabled state on a bunch of references, or maybe just a single reference, and basically just to kind of enable and disable that particular control or indicator on the front panel. So when I first did this presentation, I think about 1.5 years ago, you couldn't put property nodes inside a Malleable VI. Basically, this was because in LabVIEW there was a restriction that said any property node, you can't have a property node inside an inlined VI. And like when I was kind of opening up my demos, I found suddenly a VI that was broken suddenly started working in LabVIEW 2019. So now you can put like property nodes and stuff inside your Malleable VIs. It used to be that in older versions, so for like 2017, 2018, you'd actually have to wrap the property node part of it into a separate sub VI, which wasn't inlined. And then you can, and then you can do it that way. But yeah, this way, like now you can put property nodes in there, so you can do a lot more sort of like UI and class stuff inside, Malleable VIs with the in 2019.
I'm not sure if that was obvious, but did you mention that all Malleable VIs have to be inlined? So
Yes, yeah. So it's right at the first. So like you can basically, when you create a Malleable VI, you can, if you do file new Malleable VI, it automatically sets it as inlined. Yeah. And if you try and adapt an existing VI to become a Malleable VI, you have to give it the new extension .vim, and you also have to make it inlined. So like in the VI properties. So what I'll do is I'll come back to like the demos and stuff at the end, just to make things. But basically, I've created like a sort of set control enable that I can wire in an array of controls or indicator references. I can give it true or false. So I don't really use the 3 options usually in a like enabled, disabled, and disabled and grayed out. I either want it enabled or disabled and grayed out. So basically, like if I say true, it's enabled. If I say false, it's disabled and grayed out. But I can also, with my same Malleable VI, I can still wire in the original kind of state, the sort of the enum instead. So the next thing is kind of a little bit more sort of advanced, and I guess this is kind of working more towards like this group of doing test stand stuff. Basically, one of the things that I thought was quite useful on a project was using Malleable VIs to basically kind of reuse code between different different hardware abstraction objects. So if you're not currently a big user of LabVIEW classes, don't worry too much. I'm not going to go like really deep into like the OOP stuff, but I do think that hardware abstraction is like a really good use case of, if you're trying to support different instruments and you want to be able to have physical instruments and simulated instruments, you should probably be looking at like abstracting your hardware. And the best way to do that, I think, is with classes, because you can just write your code once and then kind of at runtime substitute in the physical instrument, substitute in the simulated instrument. And so for this project that I was working on, I was working remotely for a company in Switzerland, and I had no access to the hardware 90% of the time. So to be able to develop the code modules and the test stand, the operator interface and the test stand sequences, I created a simulation layer that allowed me to run the entire test. I could test the test sequence logic, I could test the results generation, I could test the operator interface stuff, without having access to sort of any of the hardware. So that's kind of why I think this is a really good sort of use case for this. So you can see basically this project was like for testing optical components. So we had like a LDC as a laser diode controller, and basically we wanted to be able to switch. They had two test benches that were almost identical, but they used different instruments, helpfully, with different interfaces, so USB, GPIB, serial, all sorts of stuff, custom diode controllers, and yeah, basically I had to be able to, the sequences had to be able to support working on both test stations, as well as me being able to run it at home or away from the test station. So basically, like this thing at the bottom here is basically just showing you how easily, in your code you can kind of switch between a simulated instrument and a physical instrument. So this test stand project, there we go, was basically sort of a parametric test station with sort of 8 different types of hardware with potentially 2 or 3 different instruments. So as I said before, working remotely, most of it was GPIB stuff, so sort of typical benchtop instruments, and basically like there was a lot of kind of like common code between both. So for example, I wanted every sort of hardware piece of hardware, every sort of hardware type to have its own sort of simulation interface. So this was basically like a simulation panel that pops up where I can kind of feed it values and this kind of thing. But also a lot of the instruments were GPIB based. So basically doing a GPIB read and write on instruments that have different addresses, different settings, and that kind of stuff. And I wanted to kind of not have to keep rewriting or recreating those VIs. So I kind of ended up with kind of identified these kind of a couple of sort of utility libraries, and so one of these was for my simulation instruments, my simulation instruments, to have sort of simulated tools where I could kind of sort of send messages back and forth between my sort of API calls and my sort of simulation panel, and for my GPIB to basically be able to send either just send a message to an instrument or send a message and receive a reply. So one of the features of Malleable VIs is that they can also adapt to different class wires. So if you have, basically what it allows you to do is to have 2 completely unrelated classes, which can, you can have a Malleable VI that can work on 2 unrelated classes, and as long as it has like the method or as long as they share the common method or the common property, then your Malleable VI can call that. And basically, the condition is that the VI names must match and the connector panes must also match. So kind of LabVIEW 2017 includes quite a good example of this, which is like a heating and cooling system, which basically where you have sort of your different hardware objects, so a heater, a cooler, an air conditioner, and sometimes those things are combined and sometimes not. But basically, allows you to, and you can kind of create VIs that are in each of the unrelated classes, but then your Malleable VI can kind of adapt at compile time to the sort of kind of the different class wires. So I'll show you like a demo of this because I really don't think I've explained that very well, but hopefully it will kind of become a bit more clear later on. But essentially, like what I've done here for this demo is I have basically a bunch of unrelated classes, and I want to be able to get some string data from them so that I can log it. So I think a good use case for this is like configuration. If you have like a class for for your different instruments and they all have their own configuration, and I want to store all of that configuration in a file, I can basically like wire in an array of objects and it'll get the string data and write that to a text file. And those objects don't have to be related, like they don't have a child-parent relationship. They can be completely separate. So I can, if I also had like a, operator interface settings class that also had this get string data method, then I can call that as well. And so again, to kind of show into that a little bit more, so basically for my simulation panels, I basically had a sort of a message queue. So I could basically, my API would send a message to my simulation panel, and then I'd also be able to sort of send a response back as well. So I basically created these simulated VIs here. So like sort of my read laser enable, this basically calls the simulation command malleable VI, which can basically sends it a message and then sends a reply, which is the Boolean as to whether or not the simulation panel says that the laser is enabled or not. And then basically this is the contents of that malleable VI. So basically what it's doing is it's taking in any class and it's looking if it has a read command queue method, then it will be able to kind of send it a message and receive a response. So it's useful here for my sort of simulation stuff, but also if you think about like sort of like architectures and frameworks of, this is the kind of stuff that we as LabVIEW people and test stand people do quite a lot of. I want to send something a message and receive a reply. Well, you can kind of use a sort of common set of functions for that, rather than having to keep repeating it and keep doing the same thing over and over again. And then on the right hand side is basically like an example of one of my actual like implementation classes. So talking to a Newport LDC, where I'm basically using a malleable VI to do the GPIB write and then a read function. So what this does is the GPIB, my GPIB class basically has a VI that's called get GPIB config. So it basically reads the GPIB configuration from the class and then reads and writes a GPIB command to it. So this VI will work with any class that has a get read GPIB config VI in it with the right data type. So to kind of show some of the sort of considerations of this, they all seem quite good and quite useful, but there are some sort of caveats to working with them. So the first one is obviously because it requires inlining, that kind of limits to some of the things that you can do with them. So I think the no invoke property nodes is actually fixed in 2019. There was an idea exchange thing that I kind of checked and saw if it had been updated, and I got a couple of replies from Stephen saying, yeah, it's been fixed in 2019, but without any fanfare or anything. But yeah, you can now put property nodes in Malleable VIs. You can't have any automatic error handling. You can't do any debugging. So you can't do the sort of interactive debugging. You can't put probes and breakpoints and stuff inside your Malleable VI because it kind of gets inlined when your code is compiled. There's no recursion, so you can't have a malleable VI call another one. And one of the things that, so there was a talk, did you say it was at NI Week? There was a talk at NI Week from someone from NI about like malleable VIs, where basically they pointed out that kind of every time you use a malleable VI, because it's inlined, it increases the code complexity of the VI that's calling it. So it's just something to be aware of, that if you notice that your compiles start taking a really long time, and that's because you've thrown like hundreds of complex malleable VIs on there, then it's probably because because of the inlining of your malleable VIs. So I said there's no debugging sort of inside the VI, but actually kind of as a developer, they're not really that easy to develop and not really easy to debug there. So you kind of, for sort of supporting the different data types, you're kind of having to create broken code, which as a LabVIEW developer kind of feels a bit weird. Like we want to have like, nice arrows and then these sort of crossed out hashed ones, when you have a type specialization structure. And I'll show you some of that when I do the demos. But What you can do is if you right-click on a Malleable VI, there's an option to convert instance VI to standard VI, which will basically like kind of open it out and create a new like normal VI that you can then open up and see kind of how it's compiled it. So that's quite useful for debugging. So what I quite often do is right-click, convert instance to standard VI, double-click on it to open it up, and go, yeah, that looks sensible, or okay, now I see what's going wrong, and then I just close it and do Control Z to undo it, and it'll kind of put the Malleable VI back in place. So that's like an easier way, an easy way to kind of see what's actually happening and why it's not doing what you expect. So there isn't really a runtime performance impact. So because they're kind of flattened during the compilation, like there aren't any sort of additional overheads with calling Malleable VIs. They are a new-ish feature. I mean, we're now on LabVIEW 2019, and they were introduced in 2017 and have been around for a lot longer. But I've run into like some pretty weird issues with them. So if you start using Malleable VIs and you find that your executables aren't building, that's one issue that I've had. I think if you try and build them into a project library and things start breaking, that's also an issue that I've had. And I think there was something else as well, but basically just beware that if you start using Malleable VIs and things aren't working as expected. I know certainly in LabVIEW 2017 and 2018, I've had issues with them, but they do, they kind of, with each new version of LabVIEW, they keep getting better. So I'm not sure if that issue has been fixed in 2019. I think it was fixed in like the executable build issue, I think was fixed in like 2018 SP1 maybe, or something like that. If you're using class adaptation, so like basically for it to work on different classes, I suggest using like a dummy interface class, because if you try and develop your Malleable VI on like one of your actual classes, then that then becomes a sort of dependency of it when you're kind of developing it. So I think for sort of my sort of best practice tip, I guess, is to basically like create a dummy class that has the VIs that you want to call in your Malleable VI, and then kind of keep that with the Malleable VI as your kind of like starting point, and then kind of go from there, rather than kind of ending up with sort of dependency issues of, all right, I'm building my Malleable VI, and it because I developed it based on this class, it's now pulling it into into builds and that kind of stuff. So just something to be aware of. Also, you can't call Malleable VIs in teststand. I did check this, and it's still the case for teststand 2019. So you kind of have to wrap your Malleable VIs. I mean, I wouldn't suggest if you have a Malleable VI that you just wrap just that VI on its own, because you might as well just have used a VI in the first place. But yeah, for now, and I don't know if there is a plan to allow it to work, but yeah. At the moment, you can't kind of call them directly. There's no option for that. Oh, that was it. Yeah, my test stand deployment was also not working, and that was because of Malleable VIs. So yeah, again, you kind of like, you think, yeah, I'll get stuck in and create those Malleable VIs, and then hit like a, and that was yeah.
I think in my experience of it, so if you're planning to use plugins and PPLs and things like that, stay away from that, from Malleables. And also LabVIEW 2017, I mean, you want to be LabVIEW 2017 SP1 or better.
Yes, yeah.
So don't use it on 2017 because it's really unstable. But yeah, I think 2019 is a pretty good.
Yeah, and you can't use them in NXG because, like a lot of things, they're not in NXG yet. So as a summary, I guess I'll jump onto the demos now, and then we'll come back to this. So one of the first things is, so to create a new Malleable VI, we go to File, New, and then basically we can select Malleable VI from here, or we can just take an existing VI and add the .vi, the M to the end of the .vi, and then basically make it inlined, and that will convert it to or make it into a Malleable VI. So if we have a look at the sort of ini configuration stuff, so this is I've basically created sort of a little utility library, which basically has load and save ini file, and you can see here basically what I normally do is at the beginning of the application, load it, and this will create it if it doesn't already exist, and then at the end, save it. So if we run this, we can see that sort of the initial file with the default values, and then we've kind of updated it and added picture, and that's written the new value. But then what I can do is I can go in here and I can let's add in another string parameter. Right. Oh. Sure, I have a name. And then run that again. And you can see it's basically added it in. So I can kind of wire in any data type that I like here, and it will save it to an ini file. Okay, so that's the first one. The second one is basically for my function for setting the enabled state. So I've got a bunch of user interface controls and indicators on my front panel. And then this kind of shows all of, this kind of shows all of the various options that I've configured this to work for. So if we start off by running this, so you can see we're updating multiple controls at a time. So here we'll start off by wiring in an array of references and an enum to disable everything. I'm using that stall data flow VI macro, and you can see here I can put in a reference wire or a numeric, anything I like. Here I'm setting a single control with the enum, and then I'm setting a single control with a boolean, which was so true is enabled and false is disabled and grayed out. I've then got a scalar, this is the same as that one, an array of references, but with an array of booleans. So basically, rather than setting every item to true or false, I can set the individual enabled and disabled states on the individual items in the array. And then again, the last one again is an array, so having an array of references, and I can set the enabled and disabled state of each one individually. So that's kind of quite useful if you've got a for loop and you're so these ones need to be enabled, these ones need to be disabled as part of your sort of user interface initialization. You can basically you can do that with that's all a single VI. So if I open this one up. So here, basically, I've used a couple of, three type specialization structures. I'm pretty sure this isn't the most optimum way of doing this, but have a look at Stephen's presentation, because he shows, Stephen Loftus-Mercer's Aristos Q's presentation, because he shows some of the the more information about how how this kind of works and some sort of tips about developing it. But essentially, my kind of takeaway from that was to try to get things into a common state where you can, to basically to limit the number of complex code that you have inside the type specialization structure. So the kind of principle that I've gone with here is to kind of convert everything to arrays. So I convert, if you're passing a single reference or an array of references, I build an array in here. So you can see here's, when I developed this, I used an array. So you can see that it's kind of, by having a array size function in here, that would break any other cases, because if it's not an array, then you can't use, sorry, not build array size. This wouldn't work. So I'm basically, I just convert all my references to an array. Inside here, this is where I basically accept if it's a scalar or array of booleans or enums. So if it's an array, if it's a scalar, then I initialize an array with the same number of items as the number of control references. And if it's an array, then basically this is one of the structures on the type specialization palette, which is remember where this is? comparison, yeah, assert type. So this gives you like a bunch of functions that you can use to like kind of tell it to break on specific data types so that you can specify which structure, which case of the type specialization structure should be executed. So in this case, I'm basically saying, if it's an array, then just pass it through, and if it isn't an array, then convert it into an array. And then this one here is, if it's this little guy here, is assert structural type match. So this will basically, if the wire coming in as a Boolean, well, if the wire coming in to the top here is the same type as the one at the bottom, then that's allowed, and that case will compile. If they don't match, then this basically breaks the block diagram for this particular case, and so it will move on to the next one. So it's basically a way of, here I'm forcing it to say, do I have a Boolean true false, and then convert that to enabled or grayed out. And then the other one here, I'm forcing it to say, have I wired in an enum enabled, disabled enum, and if it's not one of those, it'll break. So if I wire in anything other than a Boolean or one of these enums, it will break. The run arrow of the VI that I put this in will show it as broken. And then finally, just call the property nodes and disable it. And then the last one is here. So if we have a look at this, so this is the code. And then these are just like screenshots and stuff. But essentially, I've got two classes here that are completely unrelated. There's no sort of class hierarchy between them. But they basically, it kind of looks a bit weird. But essentially, because both of these classes have a get string data VI with the same inputs and outputs, this malleable VI and this one, which are get string data and log string to file, will accept that, accept either of those class types and be able to, get the string data. So yeah, if I run this, we can see that even though these classes are unrelated, I can kind of have common functionality, like something that does logging or configuration that can act on, sort of unrelated classes. So that's kind of the sort of end of my presentation. So the idea was to kind of introduce Malleable VIs, so kind of shown how sort of a couple of cases how I've used them and how I found them useful. Basically the features, it's basically like a VI that adapts to type. So if you're creating sort of polymorphic VIs, have a look and think, oh, should this be a malleable VI? And that kind of just highlighted some other sort of potential caveats and pitfalls that that you might run into with them. So I think on one of my previous slides I said like build early and build often. So that basically as soon as you start adding malleable VIs in, sooner rather than later that it's going to be a problem or not. That's the end. So thanks for listening. Maybe have some time for questions. Yes. And if anyone has any ideas of where they might want to use malleable VIs, then that'd be interesting to hear. But otherwise, thank you.
Sam, can you use malleable VIs for custom probes, which would basically allow you to create a custom probe which is applicable to more than one data type?
Pass. I've never tried it, so I don't know.
This is a James Powell question.
Hmm?
This is a James Powell question. He's a custom probe.
Yeah. I know one of the things is if we go back to the. So one of the other things I think. There is somewhere.
So it's called write anything. I think that's what you're looking for.
Yeah, is that write to system log?
Yeah.
That one? No, not that one.
I would imagine you can't use malleable VIs for a custom probe, predominantly because you're already in runtime at the point that you're running the VI, and when you probe a wire at that point,
That's true.
you're not compiling
Yeah,
the
true.
VIM underneath.
Yeah.
So
Yes,
that's probably the main reason why you wouldn't be able to.
Yeah, that makes totally sense.
It might be in the hidden gems, maybe actually, but there is, somewhere in like LabVIEW 2017, there's a bunch of functions that basically like allow you to wire in any data type and log it to disk. So if you've got like something that's for like error logging or debugging and that kind of stuff, where you don't want to have like pop-ups or you don't want to probe on stuff, but yeah, there's a bunch of functions in there for that. But
This is a write log, I think, is a write log.vim.
yeah, I can't find it. I'll
Yeah, we'll post it on the chat.
yeah, it might be in the examples actually. Yeah, so there are a bunch of like pretty decent examples like built into LabVIEW, so it's always worth having a look at that as well if you're looking at.
So there's a class adaptation blog by a guy called, well, I only know his user handle, Cosist, I think. I mean, so I'll post that on the forums as well. I mean, so that's quite useful in figuring out what you can do with class adaptation.
Mm-hmm. Yes, but yeah, it might be like in hidden gem, like the hidden gems package that it like links to it or something. But yeah, okay, I just can't find it. Yeah. But yeah, that's one.
Right. Any more questions?
Short one. I noticed there you've got a store VI.
Yeah.
I've never seen that before. Is that something you've developed?
Yeah. Or no. So this is again. So this is one of the default ones that's been now built into the palettes. But in the timing palette is now store data flow. And so you can drop this into any location. So even on a class wire, for example, and it will wait the number of milliseconds and also return a tick count. So if you're doing like benchmarking as well, then you can put that in and before and after what you're trying to benchmark, or get an idea. Benchmark is not the right word, but if you're trying to figure out how long something takes, then you can put that either side and read out the the time and stuff. But yeah. The number of times I've done basically the same thing and had like a delay with error wires, but sometimes you don't have an error wire or you want to do something else. So.
Do you know when that was introduced?
I think with 2017. So when Malleable VIs were introduced, they also introduced like a bunch of functions on the palette. So inside like the array palette. So there's a bunch of these. So I don't know if all of these were added in 2017. There might be some that have been added since, but yeah, from 2017, there's some sort of extra, these sort of orange functions that are sort of malleable VIs underneath that can work on different sort of data types and that kind of thing.
I'm going to have to start using something more recent than 2015.
For something like this, like Larry said, you could save this as a VIM file and you could still use it. I mean, so just it's still supported in 2015. It's not just a public feature.
I think you needed to add something to your LabVIEW ini file to activate those.
Yes, xnode wizard equals true.
There you go. What he said.
Yeah. Okay.
All right.
All right. Thanks.
Thank you so much.
Thank you, Sam.